Welcome, everyone. Thanks for joining us today from around the world in our session, today's session called Expert Model Training. We will explore different advanced possibilities for training a text recognition model with Transkribus. From the practical workflows you can apply directly to your projects. And last week we had our webinar on how to train a text recognition model in general. And this week we will dive deeper into the more advanced features and how you can use and what you can do when you train your own model. As always, I want to start with a familiar challenge we all have, we all encounter from time to time. So many of us have come across such documents and dense handwriting in general, complex scripts, and also maybe inconsistent spelling. And Transkribus is built to help unlock these kind of documents, this kind of material. And part of this is also the training of a text recognition model. Before we dive into the actual content today, I will give you an overview of what you can expect, what we will look into today. So first, I will start with a brief introduction on Transkribus and general Transkribus workflows. After this, we will guide you through the advanced settings for model training. Then we will also show you how you can compute the accuracy, how you can retrain your model, and we will also take a look at some special cases. And at the end, we will also have some time for questions where you can put your questions into the chat as usual. And we aim to keep the session as interactive as possible. So we try to answer directly in the chat, or we also leave some questions for later where we can maybe also show you some of your asked topics then in the platform directly. And we will also share the slides afterwards and the recording of the webinar, so you can rewatch everything that we are addressing today. Part of my brief introduction is also telling you a bit more about who is with me today. So we have Helene here from our comms and marketing team. She is the lead of our corporate communications. And then we have Sarah with us. She's our customer success manager, also supporting our customers with using Transkribus. And I'm here, Michaela. I am part of the board of directors at the Reed Corp, and I'm one of the two co-executive directors, and my responsibility is the go-to-market area where we and also our teams work together with customers and the community. So what is the core? Let's have a look at Transkribus and how you can work with historical documents, written documents in general, and how Transkribus can make your work easier. I think this slide shows the magic in action, so really the heart of what our Transkribus platform is. You have an original page, a document that you want to transcribe, where you want to recognize and in the end have certain results out of this recognition. So you can turn your challenging material into usable and searchable text. And in general, Transkribus is an AI-powered ally, I like to call it. So it really simplifies what is usually really slow, also sometimes really tough work when you especially work with a lot of pages, big amounts of documents, and it helps you allow focus on interpreting your material rather than wrestling with transcribing and information extraction. What I would like to do is first also take a look back, that you know what we addressed in the last webinar, where we talked about how you can train your own text model in general. So we showed last week how you can prepare your training data, how you can train your custom model, also how you use public models to support your workflow, and how to evaluate your model in terms of quality. And if you would like to refresh your knowledge on this, we also put in the link of the last webinar in the slides below at the end, and you can always rewatch this as well. And today, as said, and I will also show you what we, hopefully what comes out of our webinar today, what you can learn. I will show you this in a moment. Before, I would simply just summarize what our workflows in Transkribus look like. We have different levels of workflows, flexible workflows you can work with. So the first one is the quick workflow, level 1. We call it for really fast and quick recognition. The second one is a more guided one, where you can improve using existing models and also then edit your results. And the third one, level 3, is the custom workflow. And this is where the most interesting workflow we also show you today. So really how you can train your model, specify it to your own material, to your project, and your needs. This looks as follows. For the quick workflow level 1, you simply have to upload your material. Then you use one of the public models that we have in Transkribus available, and then you can export or share your results. As said, we have a lot of public models, over 300 already. These models are trained either by us or our members of the community. So we have users worldwide, and we have a very active community that also frequently shares models, so everyone can benefit from the work done before. Then we have our guided level 2 workflow, where there is one extra step. You can, like for the level 1 workflow, upload your material, then recognize it with a public model, and then you can, of course, edit your material if you like. So if you say there are some mistakes, I would like to improve accuracy, then you can use the editor in our user interface to simply correct the text or the layout, for example. And after this, you can share your results or export them if you want to use them in any other way. And for us today, also most important workflow is the custom workflow, where you can see there is another step in between the upload and the recognition, and this is the training step. So where you can tailor and train your own model to your specific needs and of the documents. You can improve accuracy in this way to really tailor this model to your material. And one other advantage is that you also have control of the training data that goes into this model. You can, so to speak, control what the model learns because you define the data for this. So when is a custom model useful? So when is the time you say it's better to maybe try and train your own model? There are different reasons for this, also different use cases. We will take a look at some of them also during the webinar. The first one is, for example, you have individual regional characteristics like handwriting, specific vocabulary for one region, and you want to train your own model because there is, for example, no public model available that you can use. Then a second reason is, for example, that there are individual writing styles. So like a right to left reading order, for example, also other writing styles that appear in your document. Then we also have demanding layouts, for example. So really tricky layouts, layouts that include a lot of different sets, like a newspaper corpora, where you have all these different fields you want to extract. And then this also makes sense to train a custom model to get better results for your material. In general, yeah, there are a lot of other individual applications where you should consider training your own model. And this can, for example, be when you work with abbreviations, or in the documents, a lot of abbreviations or multiple languages, for example, on the pages. So we will also look into these use cases in a moment. And our goal is that at the end of our session, you will learn how you can use the advanced settings for model training, and you know about the different techniques you can work with, how you can train your model for multiple languages, and also right-to-left scripts, how you can retrain and improve your models, and of course, how you can also compute the character error rate to evaluate the model's performance on new pages you want to recognize later. So this was a quick introduction of what this session is about, what we have in mind, and I will now hand over to my colleague who will dive into the deeper topics with you. So Sarah, you can take over.
Now we are going to talk about the advanced settings. So which advanced setting you can select when training a text recognition model. As we have seen during last session, the first thing to do is to create a ground truth data. So you need to transcribe some pages, and those pages will then be used as learning material for the model to learn to transcribe accurately new pages. You can create the ground truth pages manually, or you can apply a public model, get a pre-recognition, and then correct the automatic recognition, save it as ground truth, and start your first training. When you have your at least 20-25 pages of ground truth, you can select them and start your text and start setting up the text recognition model training. The first page will ask you to select the training data, which is your ground truth pages, and those pages are the pages on which the model is trained. Then on the second page, you are asked to select the validation data. Those pages are not used for training the model, but they are used for testing its accuracy during the training. So the model during the training will learn on the training data and then test its accuracy at every training cycles on the validation pages. To have a good validation set, you can just leave the automatic selection that is available in the interface, and automatically 10% of your ground truth is assigned to the validation data. And this makes sure that all the different kind of hands in your documents are included into the validation data. Then we have the last page, the model setup page, where you need to enter the name, description, and further information about your model. And exactly on this page, you can select the advanced settings to fine-tune the training. So let's look at the advanced settings now. The first and the most important one is the possibility to use or select a base model. If you use a base model, the training doesn't start from scratch, but from what has already been learned in the training process of this model. So usually selecting a base model helps your model to get better results and a lower character rate, because it means it isn't just trained on your own material, but it also takes the knowledge of the base model. To get better results, it's also important to select the correct base model. So as a base model, we usually recommend to select a public model trained on the same language and type of script. The base model is usually a general model. For example, if you're talking about English, it could be the English Eagle, which is our most the bigger English public model we have. And then we can select this as base model, and adding our ground truth, we are sorting of fine-tuning the bigger public model on our material. So it's really important to choose to get good results, to choose a base model that it's already performing somehow good on our documents, even if we want to improve it even further. Keep in mind that supermodels like the Text Titan can be used as a base model because they are trained with a different technology. So just remember that if you don't see supermodels in the list from where you can choose your base model, is because of that. So choose the big public model available for your language.
Can I just, sorry, quickly interrupt, because there was a question and I thought that might fit in here. There was a comment asking that the M3 model was supposedly better than the English Eagle as a base model. Do you have any experience with that?
It probably depends on the training data. So it could be that the English handwriting M3 was trained on documents more similar to yours compared to the English Eagle. The English Eagle is much more bigger, so it works on more handwritings, but probably the older English handwriting M3 model was better on your type of documents. But in general, there is no difference between the two models in terms of technology. Okay, I hope I answered. Now, another option that you can select is the number of training cycles. Usually, if for first trainings, and also if you are training a smaller or middle-sized model, so let's say up to 500 pages, you don't need to modify those settings. The training cycles or epochs is the number of times the model learns on the training data. So a model can look at the training data a certain amount of time, let's say 80 epochs. It means that it goes through all the pages in your training data, learn them, and then it tests its accuracy on the validation data. This is an adaptive number. It means that you can set the maximum number of training cycles, and this is in fact the value training cycle. So it's the maximum number of times that the models goes through the entire training data. By default, it is set to 100 training cycles. It could also happen that the models stops at 80 or 90 training cycles because it recognizes that it's not learning anything more. So it has learned everything that it could learn from your documents. And it stops early to prevent overfitting. And then we have another value, the early stopping, so the minimum number of training cycles. The default value is 20. it means that the model is forced to be trained at least for 20 epochs. After that, it looks at how the character rate is going down. If there is no more improvement, it will be stopped automatically. So just in brief, you need to remember that you can set the minimum number of training cycles and the maximum number of training cycles, and the Transkribus will automatically stop the training in between these two numbers if no improvement is made in the character rate. But by default, in most of the cases, the default settings work very well, so you don't need to touch those numbers. Other advanced settings, reverse text. Elena will talk more about later about right to left, about training right to left script model. Just remember that here there is an option that you can flag if the text was written right to left in the image, but you transcribe it left to right in the text editor. If this is the case, so the writing directions are opposite, you need to flag this option. Then there is also the option to use existing line polygons for training. As you know, in Transkribus, we work with baselines and polygons. The polygons are automatically computed starting from the baseline. So in, I would say, 95% or 99% of the cases, you don't need to work with the line polygons. Just adjust the baselines to make sure, when creating the ground truth, adjust the baselines to, in case some letters are missing, or if the baseline is too short compared to the line of text. It could happen in very special cases that the line polygons computed automatically aren't good. An example could be a newspaper where you have very big titles, and the automatic line polygons don't recognize the big title. And in those cases, you might want to modify the line polygons manually. And you need to do that for all the lines, not just for the titles. If this is your case, and you have modified the line polygons manually, you need to flag this option, so the line polygons won't be computed during the training, and the existing one will be used. But as I said, this is very rare use case. Then we have the possibility to train the abbreviation with expansion. So if you have tagged the abbreviations and written the expansion as properties of those tags while creating the ground truth, you can ask the model to be trained also on the abbreviations. And we will see it later in more detail. And then another important option is the possibility to omit lines that tag unclear or a gap. If you can't read a word or you are not sure about how to transcribe a word, during the ground truth creation, you can tag the word with the tag unclear or gap. And during the training, by flagging this option, you can omit from the training data the lines containing those words, those tagged words. Just remember, you are not skipping only the words, but the entire lines, because the training happens at the line level. There are some augmentation methods. So these are correction methods for non-horizontal lines. So if your lines are all perfectly horizontal, leave the default option, which is none. If some lines in your documents are curved, for example, lines are usually curved towards the inner margin of a volume, especially for thick volumes, you can select this option, and the model will also learn to read lines, curved lines. if your lines are rotated by some degrees or vertical, but in general they are straight lines, not curved ones, set this augmentation method to rotate. You can also convert, by default, the images are all converted to black and white. This process helps AI to focus on key aspects on the image, so the images are binarized. But you can decide to unflag this option, and it might be helpful if you have a very homogeneous training data. And then you can train tags and include property. As with abbreviations, your model learns to recognize and apply tags to words similar to those you tagged in your training data. This option works well with abbreviations and with text styles, but please keep in mind that it's not a name entity recognition. So it's a very simple method. During the training, the model learns to automatically tag the words that you have tagged in your ground truth, but just the exact string of characters that you have tagged in your ground truth. Which means, for example, that if I have tagged the word Berlin, the city Berlin, in my ground truth with the place tag, and I train the model to do that, the model will always tag. First, this tag should appear various times in my ground truth for the model to learn it. And then the model will only tag Berlin as a place. So if another place appears, London, Paris, the model won't be able to recognize it as a place name. And also if Berlin appears in a different language, like Berlino in Italian, or with a different spelling, the model isn't capable to recognize it as Berlin. So for this reason, it works well with abbreviations, but not with other type of tags. The option for the abbreviation are these ones. So in general, there are 3 different options on dealing with abbreviations. And based on your needs, you can decide to train the model to keep the abbreviated form in the transcript. You just need to simply transcribe the abbreviation as they appear in the document. You can also use special characters to that. So for example, here, Concilio, which have these symbol characters similar to the number 9. If you do it consistently, the model will learn to do the same also when you apply it. So the output is the abbreviation in the text. However, neural networks are often able to learn to recognize and use expansions, especially if they appear frequently. So you can also transcribe the expanded form. For example, here, Grazia. It's GRA with the line above the A. And if I consistently transcribe these 3 letters as Grazia in my ground truth, the model will learn to solve the abbreviations. And the output is the expanded form in the transcription. And then there is the possibility to tag the abbreviation, write the expansion as a property of the tag, and tag the abbreviation and the expansion during and train the model to do the same. So flagging the option, train abbreviation with expansion. The output is like this. So you get the abbreviation in the transcription and the tags with the properties. And then you can decide during the export if you want to keep the abbreviations, if you want to have the abbreviation followed by the expansion, or if you want to have the abbreviation substituted by the expansions. And here's an example of a model trained to solve abbreviations in medieval manuscripts. This is a public model, and let's look at one page. Okay, as you can see here, this is the automatic transcription done by this model. This abbreviation, so the letters are S, T, I, and it's correctly solved and transcribed as a sancti. And the same for all the others abbreviations. Which approach really depends on your project. Now let's look at the evaluation of the model.
One moment, Sarah,
yeah.
can we just go back? There were two questions regarding the advanced settings that I thought we could maybe reply to right away. The first one was if it is useful to retrain a model with another base model. So if changing the base model when training improves the results, or if it is better to retrain it with a new ground truth. So the effect of choosing the base model basically on the training.
It could improve the model, especially if in the first time you selected a too narrow base model, like a too specific one. Choosing a general one could improve your model. If you have already chosen a general one, I don't think you will get much more a big improvement just selecting a different one.
Thank you. And the second question was if a non-public model can be shared and used as a base model.
Yes. You can use as base model public models, your private models, or models trained by others. You need to know the owner of the model, so who trained the model, and ask them to share the model with a collection and then share a collection with you. So it isn't possible to directly share a model. It isn't possible to directly share a model. The owner of the model needs to share it with a collection, and then when you have access to that collection, you also get access to the model.
Thank you, Sarah.
You're welcome. How do understand if a model is good or not? The first element to look at is the character error rate, and you can see it in the models card here. The character error rate is the percentage of characters that have been transcribed incorrectly by the text recognition model. A 5% character error rate means that compared to manual transcription, our ground truth, only 5 out of 100 characters were incorrectly recognized by the automatic text recognition. In this case, when you see the number here in the models card, this character error rate is measured on the validation data. So on the validation pages, the 10% pages that were set aside during the training. A good character error rate for printed text is between 0.5 and 2%. For handwritten text is between 2 and 8%, and it varies a lot if you are training a model on a single hand or multiple hands. But in general, results with a character error rate of 10% or below can be considered very efficient for automated transcription and also for searching. It's always good also to take a look at the training chart. Here you see 2 learning curves, the one for the training set and the one for the validation set. But it's also important not just to focus on those numbers and on the chart, but also to test the model on some pages and visually evaluate the results yourself. Yeah, here we can see the learning curve. The x-axis is the training cycles, so the progress during the training, and the y-axis is the character error rate. And training cycle after training cycle, the character error rate goes down. So from 100%, it goes down to I don't know, 5% in this case. If the training, if the learning curves looks like this, if there are spikes, it means that something went wrong. It could be that the validation, there are some issues in the validation data, or it contains too few pages. But as I say, the Carter error rate and the learning curve alone don't fully capture the model performance, so it's always important to visually evaluate the results. Here we have an example of two models trained on the same training data. And the difference is that here we use no base model, and here a public model was used as base model. And you can see that just the base model helped decrease the Carter error rate from 7.18% to 5.86%. In addition to the Carter error rate, it is possible to calculate the accuracy of a text recognition model on new pages. It is a useful test before running a model on an entire document or collection, because we have seen that the Carter error rate is measured on the validation pages, but sometimes we also need to test it on new pages or on hands different from the ones on which the model was trained on. To do that, there is the possibility to compute the Carter error rate. We need to have two versions of the same page, the reference version, so the ground truth, and an hypothesis, so the HTR automatic transcription. So to measure, I can show you directly in Transkribus. So I have this page that I have automatically transcribed with a model, and then I have I corrected the transcription and saved it as ground truth. Now I want to see, okay, I tested three different models, the English Eagle without the language model, the English Eagle with the language model, and the Text Titan 1TER. I want to see which model, which is the best model before processing 200 pages on this hand. So I want to invest the time to correct a few pages to make this test before running the recognition on the entire collection or the entire volume. When we have at least two versions, the ground truth one and one automatic recognition, we can compare the versions. So we go here, compare with current version, and we visually see the errors. So in red, we see the wrong transcription, and in green, the ground truth transcription. So we can visually evaluate the compared transcription, and then we can also compute the Carter error rate. So here, the Carter error rate on this page is 11.67%. If I do the same with the Text Titan transcription, the Carter error rate is 6.11%. So if when choosing the model, I will decide to transcribe everything with the Text Titan because it produced the lower Carter error rate on this type of documents. And I can do the same also at the document level. I need to have both versions, but I can select the pages, go there, click Compute Carter error rate, select the version I want to compute the Carter error rate for, and here you see the average Carter error rate for my 12 pages, and I can also export the results, and in this way I can also check, okay, the model is better on certain pages and worse on others, so I can also have a look at that. And now we'll leave the floor to Elena.
Thank you. I will now share my screen. Let's see. Okay, let's just open the right slide here. So Sarah has already explained how to evaluate, and we'll now have a look at how to improve a model once we have evaluated it and we maybe deemed it not good enough. So when should I retrain a model? One thing, for example, as I already mentioned, to look at is the character error rate. So if you have quite a high character error rate of above 10%, we recommend looking into retraining a model. Of course, also just an unsatisfactory performance. If you had a look and visually try to evaluate the performance of the model and it's just inconsistent, you can also retrain a model. Other options are, of course, if there are new languages or dialects that you want to add that weren't in the original training data and you want to expand on that, then that's definitely an option as well. And also, if you created additional ground truth and you can retrain a model with this additional ground truth, we do recommend that as well. So as you can see here on the left side, we have, for example, a model, I think we showed it in last week's webinar as well, where we only have 19 pages of training data and the CR, the character error rate, is quite high. So in those cases, we do recommend, for example, creating more ground truth and retraining a model. Now, what does it look like? As we already heard, we recommend to have a first recognition with your model, then correct the text, save that as additional ground truth, and then start the new training. So with this training and retraining workflow, you have quite a good way of creating more ground truth pages to retrain a new model and create, again, additional ground truth pages with the version 2, with version 3, etc. So when retraining the model, there are a few things to consider. Of course, with illegible or unfamiliar handwriting, there will be lower accuracy, and that's why we recommend upping the training data. So already doubling the training data can lead to a 20 to 25% decrease of the error rate. One thing to consider here as well is, because we have been talking about base models before, you can use existing models as starting point to reduce the required amount of training data. However, and correct me if I'm wrong here, Sarah, we do not recommend to use the version 1. So yes, we have it on this slide. So you can select a previous public model as a base model, but not the previous version 1 model. So let's say you trained a model on, let's say, for example, a diary, which we have here as an example as well, a diary. So you have the diary version 1, and now you want to train the version 2. So we do not recommend using version 1 as a base model, but a larger public model for the training and retraining of the model. And then, of course, add the newly recognized pages to the existing ground truth and train the improved model version 2. And then you can repeat that until the accuracy stops improving. So we often get the question, how many pages is too much? So we talk here about newly recognized pages and adding those to ground truth. We recommend around 20 pages. So there's no really a point in retraining a model if you just have 1 or 2 pages of additional ground truth. But we do recommend around 20 pages to retrain a smaller model. And if you already have a large model, then we recommend around 50 or 100 new pages of ground truth. Another question that we get is, does the model not realize and correct itself if I just correct the edit and edit the transcriptions in the document editor? And the answer to this is no. So simply correcting the transcription does not improve the model. The accuracy only increases by training new model versions with updated ground truth. And I will show you what that looks like. here in the platform. So I already talked about the diary example, and we have a really nice example here of what it looks like if you add training data. So I had a screenshot of this version 1 model in the slides, and we can see we have only 19 pages of training data and a high character error rate, so almost 40% character error rate. And if we increase this and we look at version 2, we have 146 training pages, and the accuracy increased quite a lot. So we are now not just at 10%, but even almost down to 5, so almost down to 6%. And we always recommend to aim for a character error rate below 10%. If you have a character error rate of 10%, then you can speak of quite a good and reliable model already. So we now have here 146 pages, and I'm not sure, I think we had the question in the registration form as well. Some of you asked, is there such a thing as too many pages, too many training data that we add in the training? And there's hardly too many pages. So we usually say the more the merrier, or the more the better. But of course, if you use all the pages that you have of your document as training data, there is much more to recognize or to use that on. So you have to consider your project. Is this something that I can apply to other projects as well? How far down do I want to go with the character error rate? So these are a few things you have to consider. But of course, the more pages the model sees, the more pages Transkribus sees during the training, the more reference points the model will have and the better it will perform. Then also something that we get asked quite a lot is how many times can you retrain a model, or how many times does it make sense to retrain a model? There's not really a minimum or a maximum, but when you start retraining a model, so initially the CER will improve quite a lot, as you can see here. It reduced drastically, but after a while, just adding more data and additional retraining might not longer reduce the character error rate. And when this happens, the model basically has learned all that it can from the data that you're providing. So at this point, we recommend to stop the retraining of your model, and continue with the most accurate version, with the model with the lowest CER as the final model in that case. All right, let's continue. Yes, and training multiple models is a normal part of the process. Each attempt brings you closer. So don't get discouraged if maybe the second version isn't under 10%, doesn't have a CER of 10%, keep adding more training data. It's a normal part of training a custom model. Now we'll come to talking about some special cases like multiple scripts and languages. I'll try to not take too long because we're already getting close to an hour, but I think this will be very interesting for you, so we don't want to skip it, of course. Now, when can you train, or when does it make sense to train a model for multiple scripts and languages? It makes sense if your document contains more than one language, different alphabets, of course also multiple hands within the same document set, or when handwriting changes mid-document. So handwriting can change over time, and it might be by the same hand, by the same person, written by the same person, but just changes over the course of the document. Then it makes sense to train a model for multiple scripts and languages, or in this case for multiple handwriting styles. And the training process is quite similar to the normal model training, but one thing to consider is that model training for different or multiple scripts requires more training data than uniform material. So when preparing the training data, you should pay attention to really including all types of languages or scripts that are present in your material, and that they are first of all represented, but also a substantial number of each of these languages and scripts is represented to achieve this consistent accuracy across all types. We have some training data estimates here. We sent also the slides in the beginning of the webinar, so you can have a look there as well. We recommend with handwriting around 50 pages per hand. So if you have a single hand, 50 pages is a good point to start model training. With several hands or several languages, we recommend as a guideline around 50 pages per hand or per language as a good starting point to train a model. Now, the benefits of having this diverse training data is that, of course, there is the exposure to multiple handwriting styles, which gives you more flexibility, which is great, especially for historical texts. Basically, training on diverse data just makes your model more accurate, but also adaptable and consistent across different types, different languages, but also printed and handwritten text. So here are the cases where it could be really beneficial to train a model on more diverse training data, use more diverse training data. One way that you can achieve diverse training data more easily is create a sample. So this helps you create a balanced training data, basically. And this is especially helpful for this case to create the sample. Let me jump back into the platform and I will show you how that looks like. So to create a sample, you want to select the documents that you want to include as training data. I'll just select a few as an example, and then click on the action button, select create sample. You can give this a name. We'll call it, for example, ground truth 1, because we want to use this as ground truth data to train a model, and then select the number of pages that you want to include. So you can either say here 100 pages, that will be randomly selected, or you can also say 10%. And the great thing here is that if the sample is large enough, it should randomly include every type of script in the collection or in these documents that collected. And then you can click on create sample. And so let's reload the page. This should now appear as a document in your collection. Let's maybe have a look at our processes. One truth 1. And we can see here that it is in our collection for expert text model training webinar. We have our collection of diverse training data, basically. All right, let's get back. And yes, we have jumped into the platform. And now, as my last point that we'll have a look at is right to left scripts and training a model for right to left scripts. So generally speaking, at the moment, Transkribus and the Transkribus editor only supports left to right input. This means that we need a workaround for right to left scripts. So it is possible, and there are already a few models trained for right to left languages. And I'll briefly go over what to consider when preparing ground truth for right to left scripts. So in this case, it's important to first run a layout recognition to detect the text regions and the baselines. And then you have two options to prepare the ground truth data. One option is to transcribe it as left to right. Again, it doesn't really support right to left currently. Or use an external editor to also transcribe it as right to left. When you go with option 1 and you transcribe it as left to right, the important thing here is to tag reverse text in the advanced settings. So when you tag reverse text, this tells Transkribus that the transcription direction, so the transcription direction of the training data is opposite to the image. And then the model output will also be left to right matching your ground truth. When you use an external editor, you do not need to select reverse text as the transcription already matches the reading order in this case. We have already a few public models that are trained on right-to-left scripts, for example, for Hebrew or Arabic. And you can see that some of these models also show quite a good character error rate already. There's also a quite active community of users working with right-to-left scripts. So in the Transkribus team, unfortunately, we don't have an expert on this, but we're happy to introduce you and connect you with the community if you're interested, if you're working with material that you would need more information or would need experience on that. We're happy to connect you with some users and the community who are already working with that. One thing that we also just briefly want to touch on is publishing models. As I mentioned before, in our team, we don't really have an expert on right-to-left scripts, but that's why we rely on our amazing user community to also publish models. A lot of them are really great, and especially for scripts that we can't provide a big public model on, we rely on our users to contribute to the community. And maybe you're interested in other cooperations, or you know that other colleagues or research projects might be interested in applying your model. You have training data that they might benefit from of applying this model as well. So you can, of course, make your model public as well. And doing that is quite simple. I'll just show you how that works. And we'll not go to sites, we'll go to my model. And once I click on my model, I can select to publish it. Let's go here, edit. You just need to write a description for the model. I'll just copy paste the text in. And then here on the bottom right side, click on submit model for publication. And you can also choose to keep the training data private, of course. So there are a few requirements for the submission about the word count, the CER, and this also helps us and also our users to have kind of small but high quality collection of public models and also models that have been publicized by the community. And I see a small, but we already have over 340 public models. So there is a lot that our users can choose from. And we're always grateful if you also choose to share your public models with the community as well. And that brings me to the end of my part, and I will hand over to Michaela.
Oh, thanks, Helena. Yes, I will briefly wrap up with some final thoughts, and then we can also spend some time on questions. If there are still questions, or if you have questions, we can address them. I was just, we put in the slide you already know from the beginning. So what we aim for is that, you know a bit more about using our advanced settings for model training. Also how you can retrain a model, improve your model quality, how you can train models for multiple languages, and also other scripts like right to left writing, and also we talked about our character error rate, how the character error rate is computed, and you can use this to evaluate the model's performance. Just also really briefly, a bit more of a broader view here on Transkribus in general. So the main challenges that Transkribus addresses allow us to spend more time on the content itself. So instead of spending hours transcribing scripts, you can focus really on the analysis, on interpretation, on working with the material, and also by making the documents machine readable, you can search, compare, share your historical sources. easily. This is what we're aiming for. And also what we believe in general is that advanced AI tools should be accessible to everyone. So not just specialists, but also everyone else to use. And yeah, of course, the accuracy is the heart. One of the hearts of our work and your work, and Transkribus helps you achieve highly accurate recognition with complex and mixed material as well. Just to briefly wrap it up, who stands behind Transkribus? This is the READ Corp, a European cooperative society. So we're founded in 2019. A cooperative, our cooperative includes over 250 public institutions, but also private members. And we are a purpose before profit organization. So this means any income is reinvested into improving the platform and developing our features and working together with the community. We are based in Innsbruck. We also have our secure data center in Innsbruck in Austria. And our team currently has a size of around 25 people, working also all across of Europe. Here you can see some logos of our members, as said, over 250 members, spread across all over the world. They are part of over 35 countries at the moment. In our last slides, we also want to share our mission. So we are always working to provide the best tools for making history, but not only history, written text in general accessible. And we believe that the historical sources shouldn't be locked away. And with AI-assisted transcription, everyone can engage with these materials in new ways. You can try Transkribus, of course. So we put in our link to our web app here, the platform. You can also always address our help center if you need some more clarification on certain topics, if you want to read about things you can do. And there are also some more webinars to come next year. So we plan a table model webinar in January and also a webinar on field models. So really focusing on these two kinds of models and how you can train these kind of models. And in February, we also scheduled another webinar for Train the Trainer. So this is mainly for teachers and other educators. And there we want to show them how they can teach Transkribus and work with Transkribus with others. You can also find every webinar and also other short videos on YouTube, on our YouTube channel. Also this webinar will be published on YouTube. So if you want to rewatch, you can find us also on YouTube. And you can also find us on social media if you want to join the discussion, the community, the collaboration, then also visit us on our different social media channel. And I think if we have some questions, we can also address in the platform, then we can spend some more time on this, of course. Helena, Sarah, you are aware of the chat. Is there something?
Yeah, there is just one unanswered question about the reverse text option, where it is. So I'm just going to share my screen and show it. We are here. We selected the pages with our ground truth. We go there, train model, text recognition model. The first page is the training data. Then we have the validation data. And then down here, we have all the advanced settings. Here, the possibility to select a base model. And here, all the advanced settings we showed you before. And the reverse text option is here.
Thanks for this. Okay, so if there are no more questions, then I will close this session. Thanks for your participation, for your questions in the chat. And yeah, we hope you've learned how Transkribus can help you unlock your documents, how you can use the different features and settings for your model training. Have a nice day. We hope to see you again.